Hello. This video is designed to explain how to extract entities from structured data using features and functionality available in IDLE 12.7. This video assumes working knowledge of both NiFi and induction. In this demo, I'll be using 3 different input files to throw into a NiFi setup that is running on Docker. All 3 inputs feature the same data, but they all with the same structure, but they are all slightly different files. So we have a CSV file containing a header, given name, surname, date of birth, and then 5 rows containing name data and date data. So Adam Anderson, 1st of February 1980, and so on. We also have a TSV file which has the same data, only everything is tab separated rather than comma separators. So you can see the difference there. The data is exactly the same. And then finally, we have an image which features the same data, but as a table within that image. For this demo, I'll be using a Docker setup that runs NiFi. You can see a NiFi UI in front of you. This setup is a variant of the mmap setup that we provide in the 12.7 Docker release package. The important thing to note is that we have 2 induction processes set up. The first of these, table induction, is configured to handle table extraction and will receive its input from the image analysis processor. And the other one, the induction one, is set up to handle TSV and CSV input. It will receive text files as defined by the key view root on file type, while the table induction processor will receive image input, which comes from image analysis. So if we copy in the actual files, so that's the PNG file that will go into the system. CSV file for the member data values. And similarly, the TSV file as well. They will all feed into the system. While we wait for those to appear, if we look at what it should look like within content, we first look at the PNG file. We scroll down and see what it looks like within the content engine. We can see that we've got OCR output from the mmap processor. Got table, rows, and cells. The first row contains the header value, so given name, surname, and date of birth. Then we have 5 data rows. So we've got Adam Anderson, 1st of February 1980, then Barbara Benton, 2nd of March 1981, and so on. Then further down, we've got the result of the induction processor tables. So got the date of birth landmark at column 2, row 0. And further down, we have the actual data for that column. So we've got the date, 1st of February 1980 at column 2, row 1. The next one will be 2nd of March 1981, column 2, row 2, and so on. Then a similar thing for the given names. So again, the header followed by the actual data. So that's the table side of things. If we then look at the CSV file, we've got no OCR output this time because it's not come from an image, it's come directly from the CSV text file. But we do have the familiar induction output. So we've got, again, the header output. So the date of birth landmark and date of birth is the value at column 2, row 0. Then the values 1st of February 1980 at column 2, row 1. And then the 2nd of March 1981, column 2, row 2. Then we have given name, so the landmark given name at the top of the column. Then further down, we've got Adam, Barbara, Charles as given names. We'd expect them to be. Then surnames, Anderson, Benton, Croft, further down the column. Then if we look at the TSV, this should be the same output as CSV. It's the same structure, just different separators within the file. And we get the same thing. So date of birth, header, followed by the data that we saw earlier. Then the same thing for given name and surnames. So that's how the output should look in the end. Now that we've seen how the demo works, when we feed documents into it, an explanation of how everything is configured. So as I said before, we've got two induction processors set up, one to handle table extraction and one to handle TSV and CSV extraction. So if we look at the configuration for table induction, you'll note that we're not using entity or entity field for the setup. What we are using is table cell path, which defines where in the input the cell will be defined for each row. And from that, the processor will infer the overall structure of the document. So we've got OCR table row cells. So we infer that row is the name of the row tag and table is the name of the table tag in the XML that is presented to us in the document. We also require header and cell entities. So we've got header entity 0, so that will be the first column header. So we use the PII name, given name, landmark, all entity for that. So we're matching given name, landmark in that column. Then for the cell entity, we have PII name, given name, no context, all. So we're looking for any given name without context in that cell. Similarly, for header entities 1, we have PII name, surname, landmark, all. So we're looking for a surname, landmark. And cell entity 1, looking for no context surnames. And then similarly, for header entity 2, we've got the date of birth landmark, and we're looking for dates in that particular cell. So that defines what we look for within each column. So there's a header entity for each column and then a cell entity for each column as well. We are using the combined name and combined date grammars. These are available in the PII package for 12.7. So that's the table extraction. In order for this to work, we need to use the XSLT bundled up with this package, and we use this within the image analysis processor. So if we look briefly at the XSLT thing here, this is available in the package, as I say. And if we set this up, then that means we get nice table output from the processor, which the table induction processor can then use to do all its extraction work. So that covers the table induction processor. If we look at the induction processor, this is used for TSV and CSV extraction. Look at that. Again, we're using the same header and cell entity definitions as before. And we search for the content in DRE content. So we know that by defining these particular settings that we are expecting CSV and TSV input, and we look for that within the DRE content field. So that in combination will give us the output that we expect for TSV and CSV input and for tables that are detected within image input. For further information about idle functionality, visit www.microfocus.com/documentation/idle.